All right, so isosceles and equilateral triangles. So an isosceles triangle is a triangle that has two or more sides congruent. Remember, the or more was part of that definition.
Right.
The two congruent sides are called the legs. The third side is called the base. One of the things that you have to get over is that when you first learned about something called base, base always meant bottom. In geometry, there is no such thing. Because if I spun that triangle around so that the base was on top, does that change any of the relationships? No.
Well, isn't the butt kind of like above the legs, technically?
No.
In anatomy. So like it's still
Well, it depends on if you're standing up or
I guess.
hanging by your feet or.
Yeah, I mean, you've never been hung by your feet.
Sebastian, how about let's not talk?
All right. The
Stop talking.
the angle formed by the legs is called the vertex angle. The way I think about that is it's the way that the triangle is pointing. If you think of the triangle as being an arrow, the way that it's pointing is the vertex angle. The other two angles are the two base angles. They're the angles that are at the ends of the base. So we have something called the isosceles triangle theorem, which says in an isosceles triangle, the base angles are congruent. Which we aren't going to try and prove this right now because, frankly, we don't have enough information to do it yet. But I think it's pretty obvious. Think about, you don't need to draw this, but just think about if you, on this diagram, folded the triangle right along this dotted line, the two legs would match up, and the two base angles would match up, being the same size, right? I think it's a pretty easy thing to accept without proof. Later on, we'll talk about how you could prove that that's true, just not today. So let's find the measure of the other angles in each of these two triangles. So this is an isosceles triangle. Here is the base. So the two angles at the ends of the base are congruent to each other. So angle T is also 78. Nelson. I think he's really, really asleep. Nelson. Oh, there he is. There he is. Are you okay? All right. So if this is 78, so is this. Add those two together, that's 156 from 180, leaves 24. For this triangle, and it's always about identifying where is the base. You don't have to necessarily write it on the diagram, but it's not a bad idea. This is the base. So here we know that angle J and angle K are going to be the same size. So I'll take 180 and subtract 86. We get 94. Split that in half, and each of these angles has a measure of 47 degrees. By the way, occasionally I have students who go, how do you divide that in your head quickly? So honestly, what I do when I think about 94 and I'm trying to split it in half, I think about it as 80 and 14.
Oh, I was gonna say 94.
I'm sorry?
Like 90 and 4. So 40.
Oh, it'd be 45 and 2? Yeah, you can think about it. There's lots of ways you can do it. All right. We also have, page 2, the converse of the isosceles triangles theorem. He's going to fall all the way out of that desk in just a second. Nelson. Nelson. Are you with us? You can use the trick I used in college when I had trouble staying awake during a lesson. I always kept a pencil in my hand. When you start to fall asleep, your hand relaxes and you drop the pencil and you're like, oh, I got to pick it up. It works for a while. All right. So, if two angles of a triangle are congruent, then they are the base angles of an isosceles triangle. So, this one says, find the length of each side of triangle JTD. Occasionally, I'll have a student who goes, oh, I've got all three. They must add to 180. Why is that wrong? These are sides, not angles, right? The sides don't add up to anything in particular other than whatever the perimeter is. And you're like, I don't have two equal angles. Well, I bet you do after you figure out what the other one is. So let's add 58 and 64. It's 122 from 180 is 58. So that means this side is the base. The side between the two congruent angles is the base. So my equation is going to be 3x plus 7 is equal to 5x minus 11. So that'll be 2x on one side and 18 on the other. So x is 9. Now we can find the lengths of the three sides. The length of TJ will be 2 times 9 plus 15. See, that's 18 and 15 is 33. The length of JD will be 3 times 9 plus 7. It's 27 and 7 is 34, etc. Just real quick, I apologize, I wasn't paying close enough attention to the time. If a triangle is equilateral, it's also equiangular. Some of you probably already noticed that when you look at them, you're like, how do I tell the difference? They are the same. If a triangle is equilateral, it's equiangular. And if a triangle is equiangular, then it's equilateral. Works in both directions. Well, the bell just rang, so yeah. Y'all have a great day. Oh, is that the fake bell?
Yeah,
I forgot it. I forgot it. I got faked out by the fake bell.
I was like, what is he talking about?
You not want us here, Mr. Davis?
I want you to leave as soon as possible
Wow.
when it's time.
Your cranky old man G's is coming to you now.
Pardon?
Your cranky old man G's are coming to you now.
All right, so if all three sides are equal, then all three angles are equal, and vice versa. If all three angles are equal, all three sides are equal. All right, this one has nothing to do with those two corollaries, but let's find the measure of each angle in this picture. All right, so this is an isosceles triangle, and this side is the base. So which two angles are the same size? Those two. That's not helpful. Yeah, T and L. So this is 3x plus 5. And furthermore, what do we know about the angles in a triangle?
They equal 180.
Each individually?
Well, they add up. The sum is
Yeah, their sum is 180. So adding all of those together, let's see, that's going to be 10x plus 10 is 180. So x is 17. So the measure of angle M will be 4 times 17 is 68 degrees. The measure of angle L will be equal to the measure of angle T. So it'll be 3 times 17 plus 5.
We only need TLM.
I'm sorry?
We only need measure of L. Or wait. Oh, never mind. Sorry. Never mind.
So that's 51 plus 5 is 56. We could have also subtracted the 68 from 180 and split the result in half. All right, as we said earlier, your assignment is in the book.